Hello and welcome to the first video of graph theory. So basically what we're gonna do in this episode is that I'm going to give you a very rough introduction to what graphs actually are, and well, throughout the rest of the series we're gonna just slowly build our knowledge bit by bit. So graphs is a very big field, and in fact I only know just a small part of it, so I'll only be able to teach you what I know about, but hopefully that's enough to give you a general impression of graphs in general. So today we're just gonna give ourselves a very basic understanding of what graphs are, and we're gonna have a little hint about how they are actually applied in a real world. Now you see, a graph looks something like this. There are vertices and their edges, and basically the objective of graphs is to express a problem as a set of points, and these points are connected in certain ways that by visualizing our data in this manner we try to use efficient algorithms to find out certain things about the data. That is of course a very abstract definition, so let's try to make it more concrete. And one favorite example that everyone loves to use is Facebook or like other social media. Like just imagine this social media has millions of users, and if we were to store them in a giant array, we will have problems finding out even the simplest of things. For example, like if we want to find out if these two people are actually friends with each other. So well, if you had an array, you have to do some kind of a search like this. And while there are efficient ways to do search on an array, when there are so many users and possibly so many people doing such searches at the same time, all that computation is going to add up. However, if we would express the whole friend relationship as a graph, then really all you have to do is to follow that line to find out if these two people are actually friends. So yeah, basically that's what a graph looks like. Now, in addition to just points and edges, we can also express certain other concepts. For example, instead of graphs, what we can have are directed edges. That will imply somehow that we can only move this way and not the other way. On top of that, we can also give the edges weights. So for example, if we were to use a graph with each weights to model, say, a road network, we may be implying that some rules are easier to pass through than others because of congestions. So as the graphs are very versatile, that can be used to model many problems, even though on their own they're not very interesting. In fact, while we're here, let's consider several other interesting aspects of graphs as well. And let's start with what is known as a path. A lot of the time we model a problem as a graph, we may want to find a path between two nodes. So what exactly a path is? Well, as its name implies, it's just a set of edges that connect two nodes, and because we're dealing with the abstract concept of graphs, a path can actually be a finite or even an infinite set of edges, as long as ultimately it connects the 2 points we are interested in. We extend the concept of a path to a concept of a cycle. So if our path starts and ends in the same vertex, what we will get is a cycle because it is a closed loop. So yeah, while being instructional about several definitions, I hope I have also, awakened a little bit of interest regarding just graphs in general. We're going to try and keep this episode quite short. So in fact, I'm gonna wrap this episode up here, and thank you very much for watching. And don't forget to like and subscribe if